Hey guys, welcome to lesson 113, page 592 of your math book. So today's video, I'll go ahead and give you a warning. It's going to be a little lengthy, so if you want to watch like half of it, take a break and then come back and watch the other half, that's fine. So the first half, we're going to be talking about adding and subtracting mixed numbers, and the second half is going to be multiplying by powers of 10. So first off, adding and subtracting mixed measures. That means that you have mixed units. So obviously we know that inches and feet are different. However, there are 12 inches and 1 foot. So that means that if you have 14 inches, then that is the same thing as 1 foot and 2 inches, because you can't have more than 12 inches and 1 foot. Minutes and hours are two different units. We have 60 minutes in an hour. Ounces and pounds are different. We have 16 ounces in a pound, 4 quarts, and 1 gallon. So these are just some of the ones that you're going to be using today. So step 1, you have to decide if it is subtraction or addition first. Okay, once you figure out if it's subtraction or addition, then you'll be better suited as to how to start the problem. Step 2, put the larger value on top for subtraction problems. Okay, it doesn't matter how it's worded. But if it is subtraction, put the larger value on top, always. Step 3, split the problem in half, okay? And what I mean by that is draw a line down the middle to where your units are separated. So notice how I have hours on one side and minutes on the other. This will help you keep it straight in the long run. Okay, and step 4, add or subtract the smaller unit side first. Okay, so minutes is a smaller unit than hours, so I'm going to go ahead and add those. So 20 plus 10 is 30. Okay, and this just happens to be an addition problem, but we can do a subtraction problem also. Okay, step 5, same problem. Add or subtract the larger unit next. So 1 plus 1 is 2. Okay, not too bad, right? Step 6, rearrange the units that are needed. So in this problem right here, I do not need to rearrange anything because there can be 30 minutes in an hour. So 30 minutes is fine because it's not over 60. So this is good to go. And you can even write beside of it, rearranging units not needed. Okay, so that answer is perfectly fine. Rearranging units not needed. Okay, so the rearranging units would be if you have more than 60 minutes on the minute side. If that happens, then you do have to take some from the minute side and put them onto the hour side. Okay? So right here, this was the example that we just did. No units need to be rearranged, so you can have 30 minutes out of an hour. Okay? So this answer is good to go. Now let's say that you had this example, and just for argument's sake, you ended up with 70 minutes. Then that means 70 is obviously bigger than 60, so you cannot leave all 70 minutes on that side. Okay, and you've already learned this once. You're going to have to subtract 70 and 60, and then you're going to get 10 left over. Okay, and I'll show you how to do that on the next page. So just stay with me. Okay, so right here, this is the same problem, okay, that was just on the previous page. So I'm going to subtract 70 and 60. and I get 10 minutes left over. Okay? And right here, these blanks, there are 60 minutes and 1 hour. So you must subtract 70 and 60. Okay, now, this 60 minutes represents 1 hour. So what you're doing essentially is you are taking 1 hour time from the minute side and you're adding it to the hour side. Okay, so this is going to be my new minute time, but I have to take that 1 hour and add it back over here to the hour side. Because 60 minutes that you're subtracting from here, it doesn't just go away, it just gets moved to this side. And we know 1 hour is the same thing as 60 minutes. So 2 plus 1 is 3, of course. Okay, so my new answer is going to be 3 hours and 10 minutes. Okay, and that's it for that problem. So let's do some together. So sometimes you'll see word problems. So we're just going to kind of take the most important pieces out, and we're going to figure out if this is going to be a subtraction or addition. And I see a typo right there. That's supposed to say together. Okay, so the hike from the trailhead to the waterfall took 1 hour and 50 minutes. The return trip took 1 hour and 40 minutes. Altogether, how many hours and minutes long was the hike? Okay, so right here is your key word, altogether. Altogether means total, which means it's going to be an addition problem. Okay, and I'm going to put both of these times in here. And remember, I'm going to draw a line through the middle of the units just to separate them. Okay, so I'm going to add my smaller unit side first, just like the steps said. So 50 plus 40 is 90 minutes. And then 1 hour plus 1 hour is, of course, 2 hours. Now, hopefully you notice a problem, though. I have more than 60 minutes here, and I can't have that. So what I have to do is subtract 60 minutes from the 90 minutes, because I can only subtract 60 minutes at a time, because that is what takes up an hour. So 90 minus 60 gives me 30 minutes. But like I mentioned before, the 60 minutes that we're subtracting doesn't just go away, it gets added to the hour side. So I'm going to add 1 hour to the 2 hours that's there. And I get 3 hours. 2 plus 1 is 3. So 3 hours and 30 minutes is my answer. Okay, let's do the next one. So again, I have to make sure if it's addition or subtraction first. To measure his vertical leap, Tyrone first reaches as high as he can against the wall. He reaches 6 feet and 9 inches. Then he put chalk on his fingertips and jumped as high as he could, slapping the wall. The chalk mark was 8 feet and 7 inches. How high off the ground did he leap? Okay, so unfortunately there is not a key word in here. But if you can imagine this, okay, so let's pretend that this is Tyrone. Okay, there's the wall. So he touches the wall right here. But then he jumps all the way up here. So the first line represents the 6 feet and 9 inches, and the second line represents how high he jumped, which was 8 feet and 7 inches. So it is wanting me to get what the difference is between these two measurements. So it's going to be a subtraction problem. Okay? So again, I'm going to put my largest value on top. So my largest value is 8 feet 7 inches. And then I'm going to put my smaller measurement on the bottom. And I'm going to draw a line in between to separate my units. Okay, so now I'm going to subtract these. Now, do you see a problem here? You can't take 9 inches from 7 inches. So I'm going to have to borrow from the 8 feet. But I can only borrow 1 foot at a time. So I'm going to cross out that 8 feet. And if I am borrowing 1 foot from the 8, then that means that that 8 goes down to a 7. Now, how many inches are in a foot? 12. So that means that 12 inches is getting added to that 7 inches that's already there. So I'm just going to rewrite what I have over here, just so it doesn't get confusing for you. So 12 plus 7 . $19. Okay, so now I can take 9 from 19. So when I subtract 19 and 9, I get 10 inches. And then I'm going to subtract 7 and 6, and I get 1 foot. Now I'm happy because 10 feet, I'm sorry, not 10 feet, but 10 inches is lower than 12 inches. Because remember, I can't have over 12 inches in a foot. So I meet the inches requirement, and my feet is fine how they are. So my answer is that he jumped 1 foot and 10 inches off the ground. Okay? Now, we are halfway through this lesson, so if you need a break, now will be a good time to pause the video. If you are still in tune with me, then we can continue on. So the next part is multiplying by powers of 10. So if you remember, just as a reminder, these little numbers up here that's in the top corner of a larger number is called an exponent or a power. So this can be worded as 10 to the second power, or 10 squared, okay? And of course what that means is it's 10 times itself 2 times. So it's not 10 times 2. And some of you are still making that mistake. It's 10 times 10. So 10 to the second power equals 100, okay? Now, hint, the exponent represents how many times you're going to move the decimal. Okay, this is a little shortcut for you. So when we get to the next example here, then I'll show you what I mean by that. Another hint, if the exponent is positive, you're going to move the decimal to the right. If the exponent is negative, you're going to move the decimal to the left. Okay? So let's try this example together. So 6.2 times 10 to the second power. So when it says write in standard notation, what that means is you're just writing it out as a normal number, nothing special. Okay, but rather than solving this out and doing 6.2 times 100, there's a shortcut. So that 2, like I said, represents how many times you are going to move the decimal. And because that 2 is a positive 2, which means there's no negative sign in front of it, that means you're going to move the decimal to the right 2 times. Okay, so I have 6.2, so I'm going to move it 2 times because 2 is my exponent. So then technically that decimal would just be behind here. so I don't really need it anymore. So my answer is 620, and that's it. Okay, so let's do another example. So 5 times 10 to the 4th. So again, rather than solving that out, there's a shorter way. So 4 represents how many times you're going to move a decimal. Now, I don't see a decimal in 5. So what I'm going to do, when there is no decimal, you always can add 1 to the very back, and it's still the same. Okay, so in other words, 5.0 is still the same as 5. Okay, they are completely equal. But I'm not going to use that 0 right now, because I'm going to move my decimal here in just a second. So that decimal, I'm going to move 4 times to the right, and I'm moving it to the right because 4 is a positive exponent. It does not have a negative sign in front of it. So I'm going to move it 4 times to the right. 1, 2, 3, 4. So technically that decimal is over here now, which because it's at the end, I don't really need it. So what's going to go in those open blanks are zeros. So my answer is 50,000. Okay, not too bad. Next one. So again, rather than solving it out, I can do this the simple way. So 3 represents how many times I'm going to move the decimal, and 3 is a positive exponent, which means there's no negative. So I'm going to be moving that decimal 3 times to the right. And like I said before, because that decimal's at the end now, I don't need it. Okay, so I'm going to put a 0 in that open spot, and I don't need this 0 up front anymore. So my answer is 250. Okay, and also in your homework, you're going to see problems like this. Write 1/2 billion in standard notation. So what that means is 1/2, okay, is the same thing as 0.5. Okay, so what I'm going to do is I'm going to write 5 million, because half of a billion would be 5 million. Okay, and what you can do, if you wanted to solve it all the way out, which you can, it just might take a little bit of time, you would do 1 billion and then you would divide it by 2. Okay, and what you would get when you did that was 5 million. Or I'm sorry, not 5 million, 500 million. I'm so sorry, I misspoke on that one. 500 million, not 5 million. Okay, so what I would do is I would move that decimal over to make it the 500 million. So I move that decimal over 8 times. So my answer is 500 million. Now there is another example in your homework that I want to point out. So you can write this on the back if you'd like, or you can just listen. So I can't remember exactly how it's worded, but it's asking you to do 1/4 of a big number. So we'll just say 1/4 of a billion again. So then 1/4 as a decimal is 0.25. Okay, and because you are going from a billion down to millions, you're going to move that decimal over 8 times. Oh, I'm sorry, 9 times. I'm not doing so good on this one. Keep messing up. To where your answer is 250 million. Okay, and then let's say you have an example that says get 1 1/2 of a billion. So 1 1/2 equals 1.5. So then you would multiply, or I'm sorry, not multiply, but you would move your decimal over to get the answer for that as well. And I don't want to tell you all of these because they're on your homework. But if you have any questions or concerns, please let me know. And good luck, guys.